Good morning, everyone. Thank you for joining today's EAC webinar. This is Cassie Stumo. I am the marketing specialist at EAC. Today we will be talking about Mathcad Prime 5.0. We'll begin today's session with an introduction of EAC from Shannon Wilson, who is one of our Mathcad experts. And then PTC's technical specialist for Mathcad, Anji Seberino, will be taking over. This session is being recorded. Unless there are any technical difficulties, everyone will receive a replay after the webinar. Please feel free to drop questions in the chat and we'll answer them after the presentation. Shannon, I will pass things on to you.
Great. Good morning, everyone. Thank you, Cassie, for the introduction. For those of you who may not be as familiar with our company and what we do, I would just like to start today with just a quick overview of EAC and what we offer. At EAC, we are dedicated to help companies transform the way they design, manufacture, connect to, and service their products. We do this by offering a range of products and services, including CAD, PLM, and SLM software, as well as desktop 3D printers. We implement the Internet of Things and augmented reality into business strategies, help with design and engineering projects, and offer training courses on topics such as Windchill, Creo, and ArborText. EAC has over 20 years of experience in various topics in product development. We are a certified solutions provider for PTC and have been a leading PTC global service provider for 15 years. We know that engineering calculations are a critical part in your product development process, and that is why we are here today to talk about Mathcad Prime 5.0 and the new enhancements in 2D plotting. I will now hand this over to Angie, who's going to be giving us the demonstration today.
Thank you very much, Shannon. Good morning, everyone. This is Anji Seberino from PTC. I'm going to be taking you through the demonstration today, and we're going to be going through Mathcad Prime 5.0, and momentarily you'll see your screens update with Mathcad Prime 5.0. Okay, so let's go ahead and get started. So this is Mathcad Prime 5.0, and this is what we're going to be talking about today. Mathcad Prime 5.0 is our latest release of Mathcad Prime. And this release is all about 2D plots. That is the focus of the release. That is the main area of enhancements in this release. So for those that have been using Mathcad before, you'll probably know that the plots in Mathcad Prime have not contained a rich set of formatting options. Mathcad Prime 5.0 delivers that rich set of formatting options. And so we're going to go into the plots in Mathcad Prime 5.0. So in order to do so, we have to have some data. So what I'm going to do up front is just create some ad hoc variables, some definitions, calculate some results, and then we'll plot that data. And we'll take a look at how we can do it in Mathcad Prime 4, and then how we can do it in Mathcad Prime 5, okay, so that we can see what the differences are. So for those that haven't used Mathcad before, if we do have anybody joining today that's new to Mathcad, just up front, I'll say that this is engineering calculation software, and it looks like a document. It looks like you're working in a document environment. And then within this document, you can enter in math content, so engineering math, text content, and graphics, okay? And the benefit of being able to do that in a document kind of environment is that you're creating, while you're doing your engineering work, you're also at the same time creating a document that can be reused, it can be validated, it can be approved, it can be understood by anybody, okay? So all of the math in this document goes in natural math notation, okay? So just as a quick example, all of the math goes in natural math notation, okay? So if we were to take the sine of x and multiply that by the cosine of x dx, and take the integral of that from 0 to pi, we get a very small number, 0 essentially. Maybe pi over 2 is a better upper limit. So there it is, 0.5. Okay, so all of the math goes in this natural math notation. Anybody can understand this. Anybody can validate it. It's easy to understand and read. We can assign that result to a variable, and then we can use that variable in the subsequent calculation that we do. Okay, so, and if we want to define input variables, we do so either above or to the left. So now instead of raising Instead of integrating from 0 to pi over 2, maybe we want to integrate from 0 to n. Okay, so we can substitute n into the expression there and update the result. So all of the dependencies that follow get updated. Okay, so that's the gist of Mathcad. Okay, you combine math content, engineering math content, text content, graphics into a single document. The math engine is running beneath the surface of the document. It's updating results as you go along. It processes the information from the top to the bottom of the page, and all of the engineering math goes in natural math notation. Okay, so let's talk about plots. So we're going to create a couple of input variables. So we'll calculate stress using force and area. Okay, so I'm just going to make a note here. Okay, so we're going to calculate stress using input variables of force and area. Okay, so pretty simple calculation. Everybody knows how to do this. So we'll scroll down a little bit. So we're going to create a variable force. Okay, and for now we're just going to create scalar values. So we'll just initialize that to 625 kips. And then we're going to define a variable for area. So maybe we're dealing with 4.2 square inches. So now we can calculate stress. And so what we're going to do is we're going to divide force by area, and we'll assign it to a variable called sigma. Okay, so there it is. And then on the right, we can type sigma equals, and there's the answer with units of pascals, of course, because we're in the SI unit system here. And pascals is the default unit for pressure or stress in SI. So we're just going to change that unit to KSI, kips per square inch, because those happen to be the units that we're working with. Okay, so there's our stress. So the next thing we'll do is define force and area as columns of inputs, and then we'll calculate stress and we'll get a column of outputs, and then we can create a plot. So that's what we're working towards. So let's go ahead and do that. So to create columns of inputs for force and area, there are a few different approaches that we could take. Okay, so to create columns of input data, we could use a table. So we could create this by hand using a table or vectors in Mathcad Prime. We could also import from Excel, and then we could also copy and paste the data in. Okay, so we're going to use the first approach. We're going to create a table by hand. And so in Mathcad Prime, one of the new capabilities, let's go to the matrices and tables tab, is this insert table. Okay, so it's on the left-hand side here. So I'm going to click on that, and I'm going to pre-size a table. So we have force and area, which means we have two variables. So we're going to have two columns, and we'll just create about 4 rows or maybe 5 rows. And now we have this table object. So this is actually a very useful object because it allows you to create simple test cases that you want to use pretty quickly. So if you just want to take a quick look at some numbers and how those numbers are being processed in your engineering math equations and in your formulas, then you could create a table like this very quickly and just take a first order look at what your function is doing or what your calculations look like. So I'm going to label that first column force. Now this is going to be the name of the variable that stores the left column with units of kips, because we're going to type units of kips. So now the left column of numbers is stored in a variable called force with units of kips. The right column is going to be stored in a variable called area with units of square inches. So these numbers in these columns are going to replace the previous numbers stored in force and area. Previously, force was a scalar, 625 kips, area was a scalar, but now we're going to replace those variables with these data vectors. So I'm just going to go through here and fill in some of these numbers. Okay, So there's our input table, okay, and maybe we'll move it to the right just to separate it out a little bit. Okay, and now we'll actually write a function to calculate stress. Before, we didn't use a function, we just divided force divided by area. And that's fine, we can do that. But if we write a function to do it, a function being something like f of x, and if we set that to x squared, we can evaluate f when x is equal to some input value, 3 for example. So a function takes inputs. And so let's write a function to calculate force. So we're going to call our function calc force. I'm going to open the parentheses, and it's going to have 2 inputs, a force and an area. So F and A. And then the calculation is force divided by area. Okay, so functions are a little bit more versatile because they can be reused with different inputs. So, so that means that anytime I want to calculate a stress, I don't have to redefine force divided by area. I don't have to type force divided by area 30 times and make sure that I'm typing it right 30 times. I can just call calculate force for any inputs I want. So here I can actually type in 425 kips and 5 square inches and get a result. And I apologize, typo. Okay, so this needs to say force. Okay, so we can actually type it in there. And we can also evaluate our function, calculate force, when our F is equal to our force vector coming out of our input table, and area is our input vector coming out of our input table with units of square inches. And then we can type equals here to look at the results, but I'm just going to assign it to a variable called sigma 2. And then over here on the right, I'll type sigma 2 equals. And I like to do it separately. I like to define the function call and assign it to a variable in one region. These are called regions. And then look at the results in a separate region, because I just think that looks cleaner. But you can certainly do it in one continuous step as well. So we could just tack on an equal sign here. And so it would look like this. So there's no right or wrong way to do it. Both are going to give you the same answers. It's just going to look a little bit different. Okay, so that's a matter of personal preference. So now let's create our plot. We're going to plot force on the x-axis. We're going to plot stress on the y-axis. And our stress values are stored in sigma 2. Okay, so we're going to plot sigma 2 on the y-axis. So let's go ahead and create our plot. And so I'm going to the next page here. Now, in Mathcad Prime 5, we still have the original way of creating plots in Mathcad Prime. Okay, so over here on the plotting tab, on the left-hand side, there's this insert plot button, and we can create an XY plot, a polar plot, a contour plot, or a 3D plot. So all of this is still here. All of the options in this ribbon are still here in Mathcad Prime 5, and we can use these plots. Okay, and what we've added in Mathcad Prime 5, what we've added to this is a new chart component. Okay, that gives us more control and more formatting options and more functionality on 2D plots than what we have here. Okay, and the chart component, it's not on this plotting tab. Okay, so some might think it's on this plotting tab, but it's not on this plotting tab. It's actually on the math tab. So I'm going to go here to the math tab, and it's over here on the left-hand side, the third one from the far left. So this is the chart component. This is new in Mathcad Prime 5. Okay, so we have the choice. We can use the original plotting approach that's been here in Mathcad Prime all along, or we can use the chart component, or we can use both, and we can mix and match them throughout the document. So let's use the original way, okay? I'm going to point out some differences. So I'm going to insert a plot here, and then we see the plotting object added to the document. On the x-axis, we're going to plot force. So we're going to type the name of the variable force, and then for the units, we're going to type kips. And then on the y-axis, we're going to plot stress, and that's stored in a variable called sigma 2. And for the units, we're going to plot KSI. And so then we can hit enter, and so then we have a plot. Okay, so that's very quick. It's very easy. It's fast. As we're doing our work, we can just put in one of these plots. We can look at the behavior of the data, of the function very quickly and very easily. So on these plots, if we want to add another curve, okay, we'll click on the axis where we want to add. So if we want to add another set of stresses, another curve for stress, we're going to click on the y-axis data, and we're going to go to the ribbon. Now remember, we're on the plotting tab, and we're going to click on add trace. And now we can add another set of stresses. Okay, and so since we don't have a sigma 3 vector, I'm just going to multiply the sigma 2 vector times 2. Actually, let's just do that up here. Okay, so sigma 3 is going to be sigma 2 scaled by a factor of 2. Okay, and so then in here, I'm going to type sigma 3, and then this is also going to be KSI. Okay, so now we have two stress curves. Okay, and so here on the right-hand side, we can display sigma 2. Now what I'm doing here on the right-hand side, just to make it clear, there's this dotted line here that is just to the right of center. This is the margin. Okay, so this defines where the page margin ends and where you enter into the margin space in the document. So I'm writing in the margin over here. Okay, I'm looking at these vectors, these stress vectors in the margin. Okay, so that's what this is. That's what this space to the right is. So there are our stress curves. And now to format those, we would click on the sigma 2, and then we could go up to the ribbon, and we can adjust the color and the size and the thickness and all of those kinds of things. So sigma 3, I'll select that one and then change that one too. Okay. Now on these plots, so remember we're on the plotting tab, and we clicked on insert plot on the left. Okay, so on these plots, here are some notes. Okay, so I'm going to move this down a little bit, but I'm going to just make some notes here. Okay, so there's no option to add a title, no legend, no grid lines, no axis labels. Okay, so axis labels are descriptive words that describe what's going on each axis. Force is not an axis label. Force is the name of a variable that stores our numerical data. Sigma 2 and sigma 3, same thing. They're not axis labels. They're the names of variables that store our y data. An axis label would say stress. The axis label for the x-axis might say nominal force. Okay, so in these plots, there are no options to add axis labels, no second y-axis, and no rich formatting options. Okay, and so by rich formatting options, I'm referring to things like being able to format the tick mark values, right? So as you look on the x-axis here where my cursor is, all of these values for force, I can't format those. I can't change the font, the size, the color. I can't change any of that. So those kinds of things, you know, being able to really get to the nitty-gritty things in your plot. I can't format what these variable names look like. Force and sigma 2, sigma 3. Okay, we can't get in here, and we can't change the fonts for those. Okay, so those are some of the reasons why we added a lot of rich formatting options and added a chart component to Mathcad Prime and Mathcad Prime 5.0. So we're going to create the same plot using the new charting app, and you're going to see what the differences are. Okay, so so let's do that. So let's scroll down. Okay, so I'm going to anchor my cursor here. So now on the Math tab, we're going to the Math tab and we're looking at this chart component. So this chart component will actually insert a full Mathcad plotting object into your document, just like the last one, but this one has many more options associated with it. Okay, so let's insert one. And the way that we get the data into this plot is a little bit different. Okay, it's a little bit different. So here's the object. We haven't plotted anything yet. Okay, so in this object, we have an input section at the top. So we are going to define some inputs. So I'm going to right click and select Insert X-axis expression. So our X-axis, we want to plot force. Okay, so our X-axis expression is the name of the variable that stores our X data. That's force. And then let's do the same thing. Right click, insert Y-axis expression. And this is going to be, let's just start with sigma 2. Now we can hit enter, and so we have our initial curve. Okay, so now if we want to get another curve on here, sigma 3, we are going to assign another x-axis expression, which will also be force, and then y-axis will be sigma 3. So we've already seen one difference, okay, and that difference is that if we want to plot another set of stresses where force is constant, we can do that, but we still need to map the new stresses to the original variable force. Okay, so these are pairs, XY pairs of data, whereas the previous one, we didn't have to enter another X variable. So now we'll have our secondary curve, okay? And now what we can do is double click on this to activate all of those features we talked about, okay? Now, one thing that we need to look at is these numbers on the X and Y axes, okay? So if you look at these numbers on the X-axis for force, these don't really represent the data that we think we're dealing with, okay? So I'm going to type our force vector, and we're on the range or the domain for force from 425 to 580 kips, and these numbers, you know, certainly don't look like 425 to 580. So Mathcad is actually plotting the values for force in newtons. Okay, so the way that units work in Mathcad, it's units intelligent, but it stores numerical data in the base dimension. Okay, so the base dimension for force isn't kips, it's newtons. Okay, so if we type force equals, these are the numbers that Mathcad is storing for force and plotting. Okay, these are newtons because we're in the SI system, and newtons is the default unit for force in SI. So it's plotting units of newtons. Okay, so that's okay. We just have to apply a little bit of pre-algebra to rescale those units to units of kips. So what we're going to do in the input section is divide force by kips. Okay, and this is just pre-algebra. This will rescale the force numbers from newtons to kips for the plot. Okay, so I'll do that for x1, and I'll also do it for x2. So now if we look at our x-axis, this looks much better. Okay, so now we're actually seeing the tick mark values on the x-axis represent the range of data for our force. Now we want to do the same thing for the stresses. Okay, so let's look at our stresses, sigma 2. And so those are the numbers there that Mathcad is storing. It's storing the numbers in pascals because pascals is the default unit of pressure in SI. So that's not what we want. We certainly don't want to see those values. So we are going to rescale the stress vectors to units of KSI. So we're just going to divide by units of KSI. Okay, and so now if we look, we're dealing with a range of 120 up to about 300, or yeah, about to 300. Okay, so, and that's because sigma 3 is twice as big. So there we've gotten the rescaling done for the units. So now let's just collapse our inputs. We don't need to look at those anymore. And now let's double click on this object to get to all of the features that I've been talking about. So some of the things that we couldn't do before with plots, I mentioned, are things like adding a title to the plot, labeling the axes, adding grid lines, adding a legend, adding a second y-axis. So all of those things are available through this object here. When we close this, we're going to see our new plot in the document. Okay, so before we do too much in here, I'm just going to do some basic things. Now you could spend a lot of time in this object, okay, but we're just going to be on the main charting selection here, and we are going to start out with giving our plot a title. Okay, so I'm going to activate the title box, and I'm just going to say that these are our stress curves. And now we can choose if we want to display that title above the plot, at the top. So right now it's at the top. Okay, it's inside the plot at the top of the plot. Okay, but we're going to move it above the plot. Now we can't come in here and move it. We can't drag this and move it wherever we want. Okay, these are predefined choices above the plot, and we'll put it in the center, and then the probably Arial font is fine. And maybe we want to change the color. Okay, so we'll just change the color, and we can make it bold, and we can set the size. So we've done a lot of things just now that we couldn't even do before. Okay, and so then we can put a border around the title if we want to, and we can set the style and thickness of that border line. Okay, so if you want it to be thicker, you can. And we can also put a background color on the title box. Okay, so if we want the background color to be, you know, maybe some other color, light blue, and then we can set the opacity of that. Okay. Okay, so that's just the title. That's just the title. Okay, now we're going to come back in here, but let's close this. You can see the preview on the right hand side of this object. Let's close this, and what we've done is going to be the viewable plot in the Mathcad document. Okay, I don't like the way this plot looks. I don't think it looks very good, so we're going to go back in here. We're going to double click. We're going to get this dialog. Okay, and so now we're going to do some of the other things that matter a little bit more. So again, still on the main object, we are going to, we did the title, okay, but on this main styles sub button here, we're going to give the chart background a color. Okay, so we'll just go with solid color, and we can make it, I don't know, some shade of red, I suppose. So there it is, okay, or maybe let's do green. Okay, so there's that. So you can see there's two tones, the darker tone for the outside, the lighter tone for the inside. We can change the inside tone. Okay, so when you're selecting this, you really want to just set the outside tone. The inside you can change later. We're going to give our chart a border. This doesn't seem like a big deal. None of these things seem like a big deal, but they are, because if you're creating a document that you want to publish or present or share or distribute to a client, your plots have to look good. They have to have titles. They have to have a legend. They have to have probably some color. They have to look good. And so you can get that look by doing this. If you want to put a border around it, it really kind of highlights the conclusions that can be drawn from the plot. Now, We can anchor the corners too. Okay, so if I just set here, I'll set this to 30. And so you'll see that we're looking at the corners. Okay, these corners on the border, I set the anchor point to 30. And so we're going to see those a little bit more pronounced. Okay, so then the plot area, this is the inside of the plot. I'll leave it as a solid color, but if you want to do a gradient, I'll just show you just for fun. You can do a gradient like this. Okay, so in the top left, we're starting with this deep brick color, and then in the bottom right, we're finishing with white. So it does a gradient going from top left to bottom right. So let's just go back to solid and set that interior color to white and set the opacity to 100% so that it's pure white. Okay. Okay. So that's the main charting properties. So now we can go to the x-axis. This is everything we want to do with our x-axis. And I like the ability here to set the thickness of the axis. If you look at the x-axis right now, it's a very slender line, but we're going to change the thickness here so that it's much thicker. It's bold, it's heavy. Okay, so we just did that. And then for the values on the x-axis, these values, 440, 460, 480, we can make those bigger. We can set the font, the color, the size on those. Let's make them a little bit bigger. But what's really neat here too is we can offset them from the axis. If we want to drop them down a little bit so that they're a little bit lower, we can drop them down using this offset, and we can also angle them to the axis. So if we want 45-degree angle, it's negative 45 degrees. We can angle them like this. Okay, so again, very granular control around all of the formatting in your plot. That's the x-axis. So now we'll hop over to the y-axis. And while we're here on the x-axis, let's add some grid lines. So now we're going to go to grid lines. We'll activate grid lines. Okay, we can change the thickness and the style of those grid lines if we want to. We can activate minor and major tick marks. And let's label the x-axis. This is, again, something that you can't do in the other approach to creating plots. So here, our x-axis title is going to be nominal force. We're going to leave the font as Arial, but we'll make it bold, and we'll make it a little bit bigger, and we'll put a box around it, and we'll set the background color to white and pure white. Okay, so there's that. So now we go to the y-axis. Same thing. Okay, so everything we did for x, we're going to now do for y. Okay, and I won't go through the tick mark values because we've already, I think that might be redundant, but we'll probably go turn on grid lines. We'll give the y-axis a title. So this is going to be nominal stress. All right, I'll just say stresses. Okay. Stress data. There, how's that? Okay, so, and we can make that bigger. So I think that it's probably pretty clear by now that there is much more that can be done in this charting app with the plots. Now, if we go to, let's see, we go to setup, that's not what I want. Okay, we're going to go to the one, and that is the first set of stress curves. Okay, that's the first stress curve. And in the plot, you can see it has this border around the line. Okay, so that means I've selected it. That's the one I'm formatting. And I'm going to make that much brighter. I'm going to change the color to a different shade of blue. And if you want to put symbols on it, you can. And then we'll go to the setup. And this is where we define what goes into the legend. So we didn't turn on the legend. I forgot to do that. But this is going to be nominal stress. Now let's go to 2. Okay, this is our second stress curve. So let's just adjust the color of that one. And we are going to go to setup, and we're going to give that one a title for the legend. So this is going to be max stress. And then if we go back to our main chart options, we need to put the legend on. So we're going to go to the legend, and we're going to turn on the legend. So it goes in the bottom right to start out, okay, but, and that's fine. We'll keep it in the bottom right, okay, but there's some other choices here. And we're also going to make that bold, and this is the key here. The number of columns, I'm going to switch that from 3 to 1. So we'll get a stacked legend instead of a horizontal legend. We'll get a vertical legend. So I'm going to change that. Okay, so now it's stacked. And we'll put a border around that, and we'll make the background color white. Okay, so there we are. Now let's close this. And everything we've done will come into the Mathcad document. And there's our plot. Okay, so now we can resize this. There's resizing handles here. Okay, so we can make this bigger, smaller, adjust it, okay, to whatever size we want. Okay, so those are the new features for plotting in Mathcad Prime 5.0. Okay. Oh, and one thing I didn't show is the secondary y-axis here too. So if you have data that takes a different range of y values, maybe you're plotting temperature on the x-axis and volume on y1 and pressure on y2, y1 and y2 are going to have two totally different scales. So you might need a secondary y-axis to do that. So this does also include a secondary y-axis. Okay, so that's great. So again, I want to highlight just the differences. So here with this charting app, with this charting object, we have, I'm going to say richly formatted titles, legends, axis labels, also grid lines, and second y-axis, to name a few. Okay, those are just a few things. But you saw through the object all of the formatting that's available. Okay, but those are probably the things that people want the most, right? We all want to put a title on our plot and a legend and label the axes and probably maybe have grid lines. Okay, so these are the things that I think are pretty critical, but there's so much more that you can do on top of that. Now, you can copy this plot and you can paste it into PowerPoint. You can paste it into Word. And so everything that we've done goes with the plot. Okay, so two different plots in Mathcad Prime 5. The original plots, those are on the plotting tab. Those haven't gone away. They're still very useful as you're doing your work. And then the new plotting object called the chart component that gives you all of the features that you really want for creating high quality presentation worthy plots in Mathcad Prime. Okay, so I think that's probably a good summary of what's new in Mathcad Prime 5.0. We can go ahead and see if any questions have come up at this point.
Yeah,
Shannon?
thank you, Angie. Yeah, we've got a few questions in the queue. The first one is, can I set the background of a 2D chart to use a picture?
Oh, that's such a good question. And gosh, I don't think that you can. And I haven't tried it, but if I activate this and go to, of course, the main charting formatting here, for the background, this is a clear button. Okay, so this will clear everything that we've done. It's not a browse button. I wish it were, but it's not. So there's nothing in here that gives you the option to select a picture or browse for a picture and set that to the background. That would be pretty cool, but I don't think you can do it.
Okay. The next question is there a way to set the default chart formatting or to copy formatting from one chart or chart element to another?
Yeah, there is. So let's activate the object. That's good. That's also a very good question because, you know, that way you don't have to go in and set all of your preferred formatting options each and every time. So up here on the traces, this is where you have your default styles. So you can add your preferences to these. They're almost like templates. And so like this one, you would set your colors and your preferences and then just apply that to whatever chart you're working on.
Awesome. Thank you for showing that. We've got another question. With the new plots, is it possible to copy and paste the plot with all of its info, like title, legend, into Word or PowerPoint? And I think you kind of answered that earlier, that you can, right?
Yep, that's right. You can do that. You can just copy the plot and just paste it wherever you want to paste it. So it actually it is at that point, it's stored on the, once you copy it, it's stored on the clipboard, just like any other picture or data as a bitmap, and then you can paste it into whatever target destination you want to go to.
Awesome. Is it possible to do markers through the new chart app?
That's a good question too. So the markers can be added, but they're done a little bit differently. In this chart app, there's actually not a place in the options to add a marker. So there's no concrete, you know, checkbox add marker. But what you'll do is in this area for inputs, you'll just have to define a constant, okay? Just define a constant. So if you wanted to put a marker, let's say 470 units of force, we're going to define a variable in this input selection as a constant, and then we'll just plot that constant on the curve, and that's the marker.
All right, thank you, Angie, and thank you everyone for taking the time out of your day to attend. I did also want to mention 2 promotions we are currently running through the end of September. Right now, you can get all seats of Mathcad, buy one, get one half off. This is a great deal if you're in need of any additional licenses at this time. And we also have a reactivation promotion available for anyone off of support. If you are interested in learning more about either of these offers, please reach out to me for more information.
So thank you so much for joining us on today's webinar on Mathcad Prime 5.0 with Angie and Shannon. So please reach out if you have any questions. And like I said, as long as there are no technical difficulties, you'll be receiving a replay at the end of the webinar. So have a great day, everyone. Thank you.
Thank you so much.